Okay, now question 13. I think it's going to be easier if we color code these ones a bit. So if you want x as a power of like a, then you could rewrite x as a to the log base a of x. So this one, we want 10 as a power of 3, which means 10 equals 3 to the log base 3 of 10. It's just a weird way of rewriting it, and this one's the other way around. 3 equals 10 to the log base 10 of 3. This one, why do I keep writing equals 0.1 is 2 to the log base 2 of 0.1. The next row, we've got these logs with given bases, so let's color code these ones. 2 is logarithm base 10. So that's the way that goes. So here we've got 2 equals log base 10 of 10 squared. Yeah, because you take the 2 down the front and then log base 10 of 10 is 1, so 2 times 1 is 2. Makes sense? So this time negative 4 equals log 3 of 3 to the negative 4. I guess they just want us to leave it like that. I'm assuming they don't want us to have 1 on 81 or anything. No, they do. Okay, so this one would have been log base 10 of 100. This one, 3 to the negative 4 is 1 on 81. This one we've got a half equals log base 7 of 7 to the half, which is the same as log base 7 to the half is root 7. So those ones were all about just figuring out which order we wanted them written. It's a weird thing. It's being able to do that comes in useful later in the exercise. Give exact values of these things. Well, that's going to be the same as log base 25 of 45 divided by 9, which means it's log base 25 of, well, that's going to come out of log base 25 of 5. I'm going to need more room. Now, 5 is the same, because I've got base 25, I'm not used to having base 25. I can't change the base, but I know 5 is the same as the square root of 25. So this is log base 25 of 25 to the half, which means it's half log base 25 of 25. Log base 25 of 25 is just 1, so it's a half. I would not have picked that comes out as a half. Never. I'm doing every second one still, I believe. So question C. Well, did I ask you to do all of these? I hope I asked you to do all of them because these are actually quite good questions. I did not ask you to do every second. Okay, question C. So if we've got log base 8 of 3 divided by 90 minus 96, that's the same as log base 8 of 3 divided by 96, which means it's log base 8 of 3 over 96. Does that simplify? 1 on 32. Okay, which means it's log base 8 of 1 on 32 is the same as 2 to the minus 5. That's all I can think of so far. Now, you know how 2 cubed equals 8? So 2 is then the cubed root of 8, which is 8 to the half. Okay, that's what I'm going to do. I mean, not to the half, to the third. That was a silly mistake. Which means I've got log. So I'm going to take that minus 5 out the front now. just to avoid confusion, log base 8 of 2, negative 5 log base 8 of 8 to the third. Take that third out the front, I've got minus 5 times a third times log base 8 of 8, which is just 1. So I've got minus 5 times a third, which is minus 5 thirds. I love it when complicated stuff or something you wouldn't even pick. This is one of the 3 reasons I really like maths. I would never have picked that that equals that. Never in a million years. Love it. Simplify these expressions. So 5 to the minus log base 5 of 2 is the same as 5 to the log base 5 on 2 to the minus 1, because you multiply the indices with brackets. And that thing, we're going to use this rule, remember that one? So these have the same base, so it's just going to be 2 to the minus 1, which is a half. Yeah, so this whole thing became 2 because it became whatever this one was. 5, okay. Adding the indices, so these must have been 2 to the log base 2 of 3 times 2 to the log base 2 of 5. 2 to the log base 2 of 3 is 3. 2 to the log base 2 of 5 is 5. So it's 15. DE, 7 to the minus log base 7 of x is the same, exactly the same as what we did up here. So that's 7 to the log base 7 of x to the minus 1. So that whole thing just becomes x to the minus 1, 1 on x. And G, this is the same as 2 to the log base 2 of x to the x, because we would have multiplied those indices when we expanded those brackets. 2 to the log base 2 of x is just x, so we've got x to the x. Not much I can do with that. Question 16. Rewrite these relations in index form, that is, without using logarithms. Okay, we can do this. I'm going to do it a really, really complicated way, and then you're going to see a shortcut. So we've got log base a of x plus y. We're showing that it equals log base a of x plus log base a of y. What that means is a to the log base a of x plus log base a of y equals x plus y. Because remember, if I have log base 2 of 8 equals 3, then that means 2 to the 3 equals 8. It's just a different way of rewriting it. Now, this is the same as a to the log base a of x times a to the log base a of y. Log base a of x is just x. A to the log base a of x is x. A to the log base a of y is y. So we're saying x times y equals x plus y. Huh. Question C. We've got log base 3 of x equals 4 log base 3 of y. Which means I've got log base 3 of x equals log base 3 of y to the 4. And did you spot the quick way yet? You can get rid of, oh, you can get rid of the logs. If they're both to the logs, then we can just say x equals y to the 4. We don't have to do the whole long way. Like if you've got logs on both sides, yeah, you can just say x equals y to the 4. I'm going to redo this one because I'm really annoyed that I took the long way to do that. I mean, that was perfectly reasonable too, but I could have been like, well, log base a of x plus y equals log base a of, well, that's x times y, which means x plus y equals x times y. Yeah. If they're both logs, then you can do that. You can just get rid of the logs if both sides are logs. Question E. So I've got x times log base a of 2 equals log base a of y. Let's make them both logs so that we can just make the things inside the log equal each other. So log base a of 2 to the x, log base a of y, so 2 to the x equals y. FG. So we've got, oh, they've saved us a nice hard one. So we've got half log base 2 of x equals a third log base 2 of y minus 1. Now I want them all to be the same base log. So I've got log base 2 of x to the half, log base 2 of y to the third. 1, I could rewrite that as log base 2 of 2, which means x to the half, got one more step. I've got to get them to into the same. Like base 2 of x to the half equals log base 2 of y to the third divided by 2. So this 2 went down here. That's that 2. Which means now I can say x to the half equals y to the third on 2. And I'm assuming they don't want... So I've got 2 root x equals the cube root of y. It's just a different way of writing that. Or if we just want... Um, 4x equals cubed root y squared. Now if I cube everything, 64x cubed equals y squared. I only did that to get the answer. Yeah. When I say I only did that to get the answer, I only did that because I'm looking at the answers in the back of the book and it's showing me this. So I just wanted to show you how you got there from this, which is where I would have left it.